this is time to resume the session. The next session is titled Validating OpenStreetMap by Arun, Ganesh, Mapbox. Welcome again.
Okay, I'm going to be talking about validating the map. And for some of you, the term might be a little strange. So by validating, I mean the data validation. So my team, the data team at Mapbox, we are responsible for the data quality that goes into our products. And as part of our work, we continuously monitor changes on OpenStreetMap to check what is everyone contributing, checking if the quality is okay, and if there's anything to be fixed before it goes into our products. And as we do that, we come across many instances of incorrect data or somebody making mistakes or just playing around. So this will be a fun talk. It's going to be non-technical with a few visuals, and we can have a discussion at the end. Crowdsourced data projects, there's two big ones today in the world. There's OpenStreetMap project, and there's Wikidata from the Wikimedia Foundation. The OpenStreetMap project focuses on crowdsourcing geographic data, while Wikidata crowdsources any kind of structured data, which also includes geographic data. And at Mapbox, we use both these data projects to make the maps that we serve. And when you crowdsource and anyone can edit, people do all kinds of things. And here are a few examples. So cities can become shops. Here is a case of the Paris city in OpenStreetMap has become a bicycle shop, which in some ways is not too off. Or it could become an office. This is Harare, capital of Zimbabwe. The name has been changed to someone's office. And then it just shows up at a very high visibility on the map. Or this is a case in Wikidata where you can just change the name of your school. This, for instance, is a high school which has been changed by someone, most probably from that high school, saying it's not very good. So let's see, why does it happen? And what are the different scenarios? The simplest thing, you just move your mouse and you don't realize it, and you end up with something like that. So the road has got distorted. This, by the way, is in Sheffield in England. And this was on the map for 2 months before our team had noticed it, which is very strange because UK has one of the most active communities in OpenStreetMap, where everyone's looking at the map. And still, for 2 months, nobody saw this. You can delete roads pretty easy. You select a road and you say delete, and you no longer have any cars routing on it if they are using OSM engine. This is in New York City. You could change names of cities. In this case, the French name of Paris was renamed to Algeria. Or it could just be contributors trying to make the map look pretty. And not technically wrong. In this case, someone new has started adding trees and outlining the tree canopy on the map. And it's not completely wrong, but it looks very strange. Nobody does this on OpenStreetMap. Here we see someone has added villages throughout in Southeast Asia. Everything is called virus. Maybe they were trying to track spread of a disease, we don't know. And OSM has a system of free-form tags where you can keep adding tags for many things. And not all of them are documented, what to use it for. In this case, someone has added a description tag which says fertile but bald. This is a recent phenomenon, mapping for Pokemon Go. So there's a theory that Niantic uses OpenStreetMap data to find the location of spawn points for Pokemon Go. And ever since that story came out, everyone's been editing OpenStreetMap. Like never before, adding parks, adding footpaths, adding water bodies in all kinds of places, just so that it creates spawn points. And yeah, OSM is a nice canvas. You can draw anything you want there, and there you have. Someone's drawn a nice practice your drawing skills. So where do these contributions come from, which do not really belong on the map? Is it the contributor's fault? Is it the software fault? And there's been a lot of discussion on this on the mailing list and on the diary post that certain types of editors are responsible for creating and allowing such edits to happen. From the data that we have collected by reviewing change sets over the last 1 year, what we have found out that from all the harmful change sets, 60% of them come from new users who are completely new to OpenStreetMap and who do not know how the tools or the system work. In any new project, new contributors, they naturally make mistakes due to inexperience. They don't know what OpenStreetMap is for, where it's getting used, how to contribute, what is to be added, what is not to be added, how the editing tools work, and this tagging system, which is very unique to OpenStreetMap. And someone who's going there new may not have the complete idea and might just be playing around innocently without meaning to make a mistake. But the most important thing of all, not every new user is aware of a community of editors in their area on the map who are looking after edits and who are there to help them out. They don't know how to reach out to others for help, nor do they know how to get help. So that's 60% of the bad edits. Then the 40% still comes from editors who have experience. Experienced contributors to OSM usually make very large-scale edits. They edit boundaries of large countries, rename a lot of objects at once. They use very powerful editing tools, unlike new users, and they edit very important and complex features, which the tools do not make it really user-friendly to edit. There's a very high chance of a human error here, and everyone is exempt from making mistakes. It happens. And usually when experienced editors make a mistake, it is even more serious than a new user doing it. OSM is getting more new users every single day. And there's more activity than ever before, which essentially means that as we keep going on, there's going to be more people making mistakes. On the software side, there's been a lot of tools to edit OpenStreetMap which are coming new. There's a tool called Street Complete on the phone. There's Maps.me. The ID editor is getting more and more easier. And with more interest in OpenStreetMap, there will be more new tools coming in. Now, as more new tools come in, there's going to be more new users using these tools to edit OpenStreetMap. And if the tools don't really have proper help or documentation or not built properly, they are going to make mistakes on the map data. The big takeaway is don't give powerful tools to inexperienced users. That's always dangerous. But right now, there's no check on that. Anyone can use any tool, and it is possible to create damage. And it's software, right? Everything has a bug, and you never know when something is going to break. And we always need to be prepared for the worst that happens. So how do we protect the map? And this is important for all data users of OpenStreetMap, those who are using it for creating maps, for doing analysis, for critical uses like humanitarian purposes, for navigation, maybe for ambulances. You don't want the data breaking. You want it to be of the highest quality possible. So how does one ensure the data integrity of a crowdsourced project? What we have found out is we have tried many different strategies, and everything has a loophole. Each time we create a rule or we think that this is what causes a breakage, something new happens. And the only scalable way is to have as many eyes on the map as possible. And that's largely how the OpenStreetMap community also works. Mistakes happen on OpenStreetMap and as time goes on, someone else sees the mistake, they fixes it, and OpenStreetMap corrects itself. All the crowdsourced projects follow this pattern. Wikipedia, Wikidata, they're all self-correcting systems. As more newcomers come, as more users come in, they make fixes, they improve the quality, and overall it improves. But we need as many eyes as possible to make sure this process happens continuously, and its data is not hidden from the eyes of the reviewer. The big reason that many things go through the community and is skipped is that not all the data in OpenStreetMap is visible on the map. When we go to the OpenStreetMap website, we see a colorful map. But there's so much of data hidden behind the map in different tags and different geometry. Not everything is displayed on the map. And to really have foolproof community validation of data, you need local context. We can write rules for checking topology or geometry or tags. But in many cases, the real world also breaks pattern. In this case, there's a military area inside a lake. And the only person who will know if this is valid is someone from there. That is this really a protected area or if it's not. So we need someone local to check this, to be able to say if this is good or bad. We need more accessible tools for the community to review each other's contribution. Newcomers make mistakes, and we also know that experienced users make mistakes. And the only way we all can benefit is if each other looks at each other's contribution and gives each other feedback. The OSM, and over the last 10 years in the OpenStreetMap community, data quality and quality assurance has been a continuous topic that everyone's working on. There's many tools that's been built. If you go to the OSM wiki on quality assurance, there's over 30 tools listed on the page. Each one does something very specific. And none of these tools are listed on the OpenStreetMap website. So how does one find this? For a sense of scale, every single day there's 30,000 change sets on OpenStreetMap by 4,000 users. And there's, on an average, 2,000 registered users every day on OSM. Many of them who don't make edits, who just register and who have an account. But this is the scale of OpenStreetMap. It is a large global project. And there's no way a small team or algorithms can perfectly monitor everything. This is a tool that has been built by, supported by Mapbox. It's called OSM Chainset Analyzer, shortly called OSM Cha. So this was a tool which was first demoed in State of the Map Latin America 2 years back by Willie Marcel. And this was found very promising, and the data team at Mapbox has started using this to look at, to review chain sets on OpenStreetMap. And as we started using it, it allowed us to create more findings on what is going wrong, what needs to be fixed. And we have essentially started using OSM Cha as our go-to tool for data review and validation. And today, OSM Cha has just been released a week ago with a lot more new features, which can really help the community as well for reviewing each other's work. Just some other things. One can filter the edits to the map by a location of the map that you want to see what changes have happened in your area. You can filter it by a particular time range. You can filter it by the nature of an edit. So there's an automatic classification of every chain set based on certain rules. In this, we see you can filter for any chain set which has edited a Wikidata tag or Wikipedia tag. You can filter for chain sets which have edited names of cities. So as our team has kept finding issues, we have written rules for it, and it automatically flags many different types of commonly made mistakes. And this gets reviewed and fixed as soon as possible so that it doesn't get affected on any of the maps or on OpenStreetMap. And the way we also do this is by interacting with the community, that as soon as we see a new user has done something, something incorrect or does not know how something works, we provide a chain set comment and discuss with them and ask them, why did you do this? And we provide them documentation that this is how you need to map, or this is the tagging theme to follow. And this has proved really useful in helping the overall data quality of new users and converting them into experienced OpenStreetMap editors. Another very useful feature of OSM-char is the way to visualize the map edits in this tool. The history tab in OpenStreetMap shows you where edits happen, but it's very difficult to find out what features were modified, what features were added, what features were deleted. In OSM-char, there's a visual diff on the map, which highlights in red features that were deleted, in green features that were added. And you can quickly see what happened, comparing it with the satellite imagery, along with the user details, the experience of the user, and change set comment and the editor used. This is very much like another community tool called Achavi, the augmented change set viewer. One of the most interesting things that we have built into the tool is the ability to review a change set. One can mark a change set good or bad, and even categorize it in levels of severity. Whether it affects a map a lot, like changing a name of a place, or if it's just very minor, that the road wasn't aligned correctly. And at the end of it, over the last 1 year, our team has reviewed over 100,000 change sets on OpenStreetMap. We do this every single day. And every single day, we find change sets to be fixed, and we fix them immediately as soon as it happens, before the community is able to get to it. At the end of it, what we have built is a training data set that all these list of change sets, along with categorization, could be very valuable for machine learning experiments in future, and to find out how to programmatically find issues and fix them. There's various ways to contribute. The source code of OSM-char is available on GitHub, as well as the functions which flag certain categories of change sets is also available. And anyone can contribute to these rules and write your own detector which you feel is valuable for your local context or which has not already been done. Thank you. So we have an OSM-char workshop on Sunday by my colleague in the data team, Manohar. And for anybody who is more interested in using OSM-char, how it works, and also the various features of it, do attend that workshop. You can get in touch with me at this email ID, and really love to hear more ideas on how these systems can be improved, what alternate strategies we have for data validation, and for improving the quality on OSM. If we have time for questions, we can do that.
If you have questions, raise your hands, and staff is bringing the microphone for you.
Are there any existing?
右側の方お願いします。
Have you at Mapbox your own copy, which is more clean than the official OpenStreetMap database?
Yes. Yes. So what we do is we create a copy of the OpenStreetMap database along with augmented features and other open data sets. So we don't really have just OpenStreetMap, but we have OpenStreetMap++ with different data sets like natural earth, as well as learnings from different systems, which make sure that bad edits don't get through to that copy.
And how far are your machine learning algorithms already applied for your internal use?
So far, we haven't applied it in terms of machine learning. We rely a lot on using detector rules that we have programmed, as well as human review of different change sets. We are doing experiments with machine learning, but yeah, I can't say the results have been too successful for us to give very accurate results that we can rely on. And yeah, our end learning is, even though we have reviewed 100,000 change sets, we still need to know a lot more. So the way the different types of bad edits happen on OpenStreetMap is just so varied that it's very difficult to write individual rules for it. We need like a larger collection of things that go wrong and really build this database much further before we can do meaningful machine learning on it.
Thank you very much.
Any other questions? I also have a question. Yes. Do you have any public document for the validator to use the OSM chair or other validation tools?
Yes, so both these, the detector repository has a contribution document on how you can write the validator rules. OSM-cha, the homepage, has a full documentation of user guide, how OSM-cha works, how one can use it. And we'll be doing the live demo in the workshop, so anyone can.
That's very great. And I'm also interested in a translation of the documentation. The very active OSM mapper is not fluent for the English sometimes, so the translation is also to help the OpenStreetMap mappers to validate the data. Do you have any translation project or not?
This is a great question. So at the end of it, OSM-cha needs to be used by as many people and as many contributors as possible. Currently, we haven't localized OSM-cha yet, but this is completely something that we'll be doing soon. Mm-hmm. And be using Transifix, just like all the other OSM tools.
Now, I think the localization of application is not the important. The documentation and share the know-how of the how to validate the knowledge base of the how the mappers make mistake is very important to translate to the local languages for the share the knowledge of the how to validate and the good quality, how to achieve good quality for the map.
Yeah, this is this kind of documentation. We have the Mapbox mapping guides, which has already been translated to Japanese, so we can always expand on that, and we'll always have space for community documentation and translation contributions.
Great, thank you very much. Do you have any other questions? Again.
You said 60% are new users, but still there are people proposing that mappers should get a reputation, a kind of tag. Are you in favor of introducing a reputation to, as a metadata to every OpenStreetMap registered user?
Personally, no. Mistakes happen with everyone and not just new users. What new users need is more assistance, and system should make it easy for the community to reach out to new users and find them and provide them help as soon as they start editing. And that's where the gap is right now. That new users start editing and they make mistakes, and after a while someone else finds it and then they get angry, they put negative comments, and then the new users, they lose interest in editing. So there definitely needs to be a better system to allow new users to come into the project. And this is true for all the other open source projects, even like Wikipedia, which has found it even more difficult to attract new users since the existing community tends to be hostile. So I don't know if reputation solves that, but I think we need systems which are more friendly towards new users.
Any other questions? Any comments?
Thank you for your presentation. I want to know is there any indicator or quantitative value to represent the quality of the map? I mean, for example, I have read about the Wikipedia. Its quality is equivalent to the, for example, encyclopedia to know the failure in the some a page. So if you have such an indicator, I want to know.
There has been many users who have actually attempted this. So unlike Wikipedia, which is a hot research topic in academia, not much research has been done on, or structured research on OpenStreetMap data quality. The ones that have been done has been by Pascal Nice and Jennings Anderson. So these are two names you should look for. And the big difficulty in evaluating data quality of OSM is finding a reference data set to compare with. And because there is no other open reference data set, it's very hard to methodologically evaluate data quality. One way to do that is by looking at QA errors in the map data. So this is topological errors or data which break certain rules. So on the OSM wiki, there's a quality assurance page which has a list of tools which generate reports of errors in the data. And this can be used as one of the metrics. But it doesn't really capture everything that could be wrong or missing in the data.
Thank you.
The next question is from left side.
Thank you. Mine is more a curiosity. I want to understand if you inside the Mapbox, if you in your copy of OpenStreetMap data, you collect all kind of tags or only some kind of tags. In this case, if you try to validate the data.
The end product of Mapbox data is what is called the Mapbox vector tiles. So, and this vector tiles does not have all the OpenStreetMap tags. So essentially what happens in the backend is OpenStreetMap data comes in. We have other data sets added. It's converted to vector tiles, and many of the tags are mapped onto new tags or just dropped, which are not required, to maintain the file size, as well as what is needed for a product. So all the validation happens before it becomes the vector tiles. So once it's vector tiles, many things are just cut off.
You don't have problem with the mix different license of data?
All the data we use is public domain. So we mainly use natural earth. We use Wikidata with OSM.
Thank you. Any other questions?
Do you have any plan to make OSM nodes validator? I think OSM nodes is very messy. For example, many persons add OSM node for personal comments on the POIs. So I think nodes should need validator also.
Yeah, that's a good suggestion. We haven't started looking at OpenStreetMap nodes. We add nodes in places where we want the community to review certain areas, but mostly we comment on the user's chain sets. This is how we use chain set comments and nodes, but we haven't looked at validating OSM nodes if it's good or bad. We'll probably do that sometime in the future. Are there any users of OSM-cha here? It'll be nice to know. Has anyone used OSM-cha before? Oh, wow, there's quite a few.
Okay, it is time to finish. Thank you very much for the good presentation, and thank you for the good discussion. The next session is titled OSM History Analysis Using Big Data Technologies. I need glass to read small characters. By Martin Raifer, Heidelberg University.
Yeah, hi. In this talk, I will be presenting the data analysis platform that we are currently building over at Heidelberg University, more specifically at the Heidelberg Institute for Geoinformation Technology, which is part of the geoscience group there. Now, the reason we are building this data analysis platform is focused on one of the research topics we have at the Institute, which is about the evaluation of OSM data quality. And we want to do that by generating various statistics about OSM's data, and more specifically how it evolved over time. And we also want this system to be very efficient, so that a researcher can implement a new data quality metric and have the results immediately or very quickly, so that there's a tight feedback loop and one has almost immediate results. So speaking about data quality is quite interesting because it's a thing that one typically has a quite good intuitive feeling about what it should be, what data quality means. But specifically for geodata, it's actually quite hard to define it objectively. One finds that there are different aspects to data quality. For example, one can speak about completeness of a specific feature, like in OSM, are all the schools mapped or are some missing? And at the same time, you can speak about accuracy of this data. Are they tagged with the correct categories, or are all the necessary attributes there, for example, the names of the schools, or many different other aspects of data quality are there. Now, typically, when one talks about data quality, one also has a specific use case in mind. For example, if I want to build a bicycle routing navigation app, for example, then I probably don't care so much about attributes that are focused for cars or railways, for example. So in that case, one talks more like about fitness for purpose also. Now, quite a lot of research is currently about intrinsic data quality measures. Intrinsic data quality measures are, contrary to extrinsic data quality measures, don't require an external data set for reference. And this is very interesting for OSM because typically you wouldn't find really very many data sets to compare OSM against because either they are not global or not available under reasonable terms, let's say it like that, or limited to a very narrow feature type, and OSM is really more about everything. So how intrinsic data quality measures work is basically you start by finding some patterns in the data or in the real world, and then check the data if it fits to the patterns. For example, one of such patterns could be that you notice that a village typically has some roads and some houses. And if you then find some place node, some village node in OSM where there are no roads and no houses around it, then either the place node is not correct, or the position of it is not correct, or the roads and buildings are still missing. And another measure that is very often used in research is when you look at the amount of data that is in OSM for a specific feature type. For example, the number of schools in a certain country, or the total network, the total length of the road network in one. And if you notice that this amount of data initially grows very fast, and at a specific point doesn't continue to grow at the same speed anymore, then one of the reasons for that could be that, well, if all features are already in OSM, then there's no reason to map anymore. So if you find such a situation, and also find additionally that there are still mappers active in this region, then it's a good way to assume that the data quality is, or the data completeness is quite high in this region. Now, what do we require for our data analysis platform to do this kind of analysis? At first, it needs to be a flexible system, so not limited to a specific feature type, also not limited to a fixed set of dates or a fixed geographic region as well, or geographic resolution either. And also it needs to be fast enough to work at the global scale, and it should provide access to the full raw OSM data. Like, we want to also have meta attributes there, like the user IDs, timestamps, and we also want to be able to access OSM data that's maybe broken, so like a multiple ground that's not closed. We also want to do statistics about these data. Now, we found that existing methods typically fail in at least one of these points. So research have been using tools like the Overpass API, which gives you access to all the raw data, but for most applications doesn't work on a global scale. Or people have been using OSM history renderer importer for doing intrinsic data analysis, but it typically also doesn't scale up to a global region, and also doesn't give you access to the full raw OSM data. And what you can do is using old planet dumps and process like different attributes for individual timestamps, like maybe for each year or for each month of the year. It works, but it's really slow. And if you have your results and want to change a small parameter, then you have to regenerate the whole thing again, which is not so nice. So therefore, we are building our own thing. It's called OSHDB, in analogy to the OSH file ending of the OSM full history planet dump files. Now, the system is mostly built around the so-called MapReduce principle that allows you to do parallel processing of data. Now, let me explain this by a small analogy in real life. Let's say you have just baked a really large cake and want to find out how good it is. You could like eat the whole thing alone, but that would take a long time and maybe you have some bad stomach afterwards. Now, a better solution would be to divide the cake up into smaller pieces and invite some friends over and have a cake tasting party. So in our case here, the cake would be the OSM history planet dump, and yeah, the friends would be multiple computers. Now the question is, how do we actually divide up an OSM history planet file such that it can be processed in parallel? Just like in the real-world case, where it's quite obvious how do you cut the cake. You cut it vertically, like a pie chart, and not horizontally, where the first friend gets only the cake base, and the second one gets only some cream, and the last one gets the cherries on top. We also want to divide the OSM data into chunks that make sense, and where each computer then can generate statistics independently of other chunks, let's say like that. And what we use is, at first, we divide the world into rectangular pieces, like a quad tree. You heard about that. We use a slightly modified version of a quad tree that allows one to not store only points, but also features that have a spatial extent. It's actually quite similar to the indexing scheme that's also used by the Overpass API, if you're familiar with that. So that allows us to store the data in individual cells that can be processed individually. Now, inside each of these cells, we store the actual OSM data quite similarly to how it's stored in a OSM PBF file. And use a few tweaks here and there to be able to access individual features without having to parse the features that came before, but not a huge deal. And the one major difference is that for each OSM object that is either a array or a relation, we also immediately store their child elements as well. So if you have doing processing, if you have find array, then we also immediately have its nodes available without having to fetch them from somewhere else, which would slow the processing very much. Because what you find is typically if you have an array or a relation, you actually do want to generate their geometry in order, for example, to calculate the length of a road piece or the area of a forest somewhere. And for that, you do need the children. Okay, now in our system, it's implemented in a way that it doesn't really matter where these data cells are stored. It can be stored in just a local database where only one processor or only one machine is working on it, or it can be stored on a distributed cluster of machines. Let's say that our system can use different backends. And for the distributed system, we use Apache Ignite, which is a kind of all-in-one big data library system, which makes it quite easy to implement such MapReduce-based data processing. Now, what you also have to keep in mind is that this system should be as easy to use as possible. So the actual programming should be easy, and complicated stuff like how to assemble the geometry of a multi-polygon or stuff should be already taken from. The library should also do this work for you. And actually, we do implement this. And going back to our analogy from before, this would be like to give your guests at the cake tasting party some forks, for example, to actually eat the cake so that you don't have to use their bare hands. Now, in our case, this looks about like this here. I have here two code examples. In the first line, you see that in here we are creating a new database, OSHDB database. In this specific example, the Ignite version of it, but as I said before, it can be also run locally if you just want to do some quick tests. And immediately afterwards, you say here, I want an OSM entity snapshot mapper. That means I say that my analysis is based on attributes that I can calculate from OSM entities at given snapshots in time. For example, if I want to calculate the number of schools in a certain country, maybe for each month of all years since 2008 until now, then I use this command, and in this next line, I give it the list of timestamps that I just mentioned. And then I set some bounding box, some geographic filter, and then I say I only want, in this example here, the OSM ways to iterate over, and filter by some OSM tag. Here are the highways. And last but not least, I actually provide the system with the function that should be calculated for each of these OSM entities snapshots. What I do here is just I get the geometry of this entity snapshot and calculate its length. And the summation, aggregation, and all of that is done by the library itself. If you want to do something more complicated, then you would just expand this function here. Now, there's also a second mode of operation here, which we called the OSM contribution mapper. Basically, the difference to the last example is that here the analysis function is called for each modification of the object. So not only for the given timestamps, but also for each intermediate version or modification when the object was modified. And by that, you, for example, also get access to stuff like deletions of data, or you can, count, for example, count how many times objects' geometries get modified or whatever. Now, when doing an analysis on OSM, history OSM data, you have to keep some things in mind. For example, that the OSM API and also the OSM data format has not always been as it is now. Now we have the API version 0.6, but for example, in OSM API version 0.5, there were no change sets. So basically, if you look at old data and see some change set IDs, then you have to keep in mind that this doesn't actually represent the same meaning as current OSM change set IDs do. Also, OSM tagging has changed over time. So, for example, if you're looking at a specific thing in OSM, it could be the case that it was being used using, it was being mapped using a different tag in the past. And also, I forgot to mention, even more important, in OSM API version 0.5, before that, actually the modifications or the OSM history doesn't actually make that much sense, since before that, if you uploaded a new version of an OSM object or deleted one, the changes were permanent. So basically, the OSM history really only goes back until late 2007. So yeah, you have to know that. And yeah, also the ODBL was introduced at some point, and that means that current OSM history planet dumps don't include some data from before 2012 that was not compatible with the ODBL. Which wouldn't be so much of a problem, but in some cases you have like a way that it's missing half of its child nodes, or a similar case where one object is missing some intermediate versions of it, and you really don't know until which point a specific version was actually valid. So what we choose as a solution for this is we circumvent it by using an old CC BY as a licensed planet history dump for data that is older than 2012, basically. And for newer data, we use a recent ODBL licensed planet dump. Now, I show you some examples that can be generated by our OSHDB platform. The first example is around the road network in Italy. Chosen Italy here at random, more or less, because it's a country that is not fully completed yet in terms of its roads, but it's getting there. And you see the beginning between 2008 and maybe 2012, 13, the growth was about linear, and after that it starts to level off. And you could maybe assume that the total length will be around 600,000 kilometers. And interestingly, if you look it up in the if you look Italy up in the CRE World Factbook, it claims that Italy should only have 350,000 kilometers of paved roads. So either OSM is horribly off or not. Now what you can do here is also you can take a look at individual road types in more detail. I've split up here in the respective OSM tags. And yeah, there are several things you can see here that the more important roads are getting this leveling off earlier than residential roads or unclassified roads, for example, which are here on the top. Yeah, then you can also like say, why stop at paved roads? Why not also include some forest tracks, paths, cycle roads, or footways, and yeah, you can maybe get a hint that these kind of highways are in Italy not yet completed. Now it's also important to note that we've also always been using the total length in kilometers of the roads and didn't just count the OSM ways that have the highway tag, which would be much easier calculation, also in terms of computation. But if you compare the two values, you actually see that there is a difference, and you cannot just linearly extrapolate one from the other. So now a slightly different thing that you can do on our platform is count the unique users editing a specific feature over time. Like here, again, for the roads, and each bin represents the number of active users in the specific month. Now, yeah, what's interesting here to see is at first that there's some amount of seasonality, like more edits in the summer months than around winter. But towards the last few years, you don't see that so prominent anymore. Who knows why? Also, the amounts of users editing roads seem to be slightly declining in the last years, but that trend is not very, it's not so clear yet. But could be related to the leveling off that we saw earlier. There's not that much more to add, then there will be less user editing. Or going away from roads, you can also do analysis on land use areas, for example. Like here, I've chosen the 5 most prominent land use classes according to the OSM land use tag, and yeah, summed up their areas over time. And if you compare this to the total area of Italy, it turns out that until now only 20% of the, about 20% of the area actually is covered in some land use area. So there's still some work to do. Good, that was it from my side. Thanks to Klaus Stiftung to support this project. You can contact me under this email address.
Yeah, thank you. Thank you for presentation. And if you have any questions, please raise a hand.
Oh, by the way, the whole thing is not yet open source, but it will be soon. Oh, here's a question.
Thank you, Martin. Your analysis on road length, you mentioned that the Italian roads are double of what it should be. how much do you think is because of in OpenStreetMap for dual carriageways, highways are traced twice? And does your analysis somehow account for those as well?
Our analysis doesn't account for that, but it should be only a small factor, since typically in Italy only the motorways and maybe a few primaries are actually dual carriageway, and that should be less than 10,000 kilometers. Or maybe 20, but it wouldn't matter too much.
Any other questions? こちら左サイドお願いします。
Hi, Martin. Can you give me some data related, the data that you showed? Now I explain you better. I want to know how big is the history file for Italy, and how much time do you need to calculate the graph that you showed before?
Yeah. I don't know. Something like this takes only few minutes, or even
with one machine, two machines?
Yeah, on one machine with 4 cores, it takes few minutes, 2 or 3 minutes.
2 minutes to calculate, and how much big is the file?
Yeah, exactly. Our data files are a little bit larger than the raw PBF data files, because we do this resolving of the child elements, which then are multiple times in our data set. But it's the same order of magnitude. Like the whole planet is a few hundred gigabytes.
Do you plan in the future to have the access to the API to show every day, for example, I want to say every day some statistics related to the world or some nation?
Yeah, if you want to make also tools about...
because I think this is wonderful if it's possible, if very fast.
Yeah, it's in the pipeline, probably not going to be available tomorrow, but we want to make also public APIs available that leverage this data, and maybe also provide for download the preprocessed files that you can run these scripts on your own machines if you want to.
I'm waiting for this.
Thank you very much. Any other questions? Okay. Thank you very much for sharing good information, and thank you for the active discussion. Okay, next is the last session. The title is Analyzing the Positional Accuracy of POIs Using Spatial Association Rule Learning, presented by Alireza Kashian, Center of Disaster Management at University of Melbourne. Before starting last session, I would like some announcement from the organizer. You can pick this small brush. This is a QR code for the group photo, and also the eyes diners map is voluntarily make the local organizers to make a U map to the some bars and the pubs in the eyes city. This is you can pick on the in front of the sponsors booth. Good night.
Hi, how are you? Okay. Do we have it on the screen?
飯田さん、自分オフにした方がいいです。カメラを。
Okay. Is it fine? Can I start?
Okay. Perfect.
Yes, thank you. Okay. Thank you. I'm actually because I don't have my picture over here, so I'm not sure if you can see me there or not. But first of all, I would like to thank Rob and the team for kindly facilitating this remote presentation. I wish I could be there, but actually due to unforeseen situations, I had to cancel my trip. My name is Alireza Kashian. I'm actually doing my final year PhD at University of Melbourne, and at the same time I work at the Center for Disaster Management and Public Safety. My advisors and the team members are Prof. Raifer, who is head of our center, Dr. Richter from Umeå University in Sweden, and Dr. Chen, who is also a research fellow in our lab. I'm actually very excited to present the analytical tool that we have developed in recent months. So let's begin. Let me begin straight away with the problem that I'm going to challenge today. As you know, we're not 100% sure if all existing or new added points of interest to the OSM are semantically or logically very well positioned in OSM. Some questions like, as you see on the map, is like, is it logical to have a nightclub very close to a hospital if someone tries to register a nightclub close to the hospital? Or maybe another question could be like, how far a ferry terminal can be away from a body of water or river? These questions are actually telling us that we have to be careful about letting people adding new points of interest to the map. But how these errors are actually created? Newbies are actually, amateur new users are creating lots of errors, as we know. Vandalism, intentional damages are always there. We have seen it in Wikipedia, and we have also some records on history on OpenStreetMap as well. We also have lack of local knowledge, so many of people who are contributing are not living in that local area, so probably they're making some mistakes. And sometimes we're using the satellite imageries and they're low resolution, so probably it's very hard to pinpoint the correct position for a point of interest. There are existing tools to monitor and fix these problems, and I'm sure, because I have not seen the presentation today, but I've seen the presentation in previous OpenStreetMap conferences, and I've seen that it's fully covered about especially the tools that we can monitor and fix the problems like who did it or Osmos or Keep Right. But actually all these tools are helping us to dig into the existing data and trying to figure out where the problem is situated. But what we are proposing is a bit like different, which I'm going to present in the next slide. We all know that contributors invest a lot of time and energy to build maps, and also we know that the ultimate goal is to have a good quality, trustable, and useful map. But we need an automatic live error detection technique to save time and energy for editors, and I think that that's not the option. That's a real need. We want finally to have something like to say that OSM quality is guaranteed, because that's a question from the official data providers that OSM is not at the stage of at the stage of quality that we can use it in official applications. So our solution for tracking the points of interest and their position on the map is the OSM POI analyzer. This is an analytical tool that you can access through the address openstreetmap.me. If you have a laptop, you can quickly check it out. We investigated the problem from different dimensions, including checking the positional accuracy, logical consistency, and completeness of points of interest in different cities of the world. And we decided to develop a platform which actually we think it can help the OSM community to dig into the point of interest data and find what relates to what and why these relations are existing. So what does this tool do? As you know, thousands of new pois are added daily to OSM database. We should also, I've seen one of the presentations from the Maps.me people that when they added the Maps.me, many people actually started to add point of interest, and thank you for them to make this process faster. So we know that maintaining, validating, updating point of interest locations is a very time-consuming task. At the core, our tool generates recommendation score about probability of existence for each new added point of interest to OSM. So it's a recommendation system at heart. It can also be used to validate previously registered point of interest, which we call them existing points of interest. On the backside, we developed artificial intelligence techniques to discover the coexistence relationship, which is very well known in academia as a co-location patterns between POI pairs. Our tool is currently covering 6 sample cities and 17 different points of interest as a beginning. All OSM editors, OSM contributors, academic researchers can benefit using this tool, and we believe that and our early discoveries are actually showing that how OSM tags are inconsistently used throughout the world. And we also discovered that cities are built based on different urban design scopes, and so relationships and the patterns we find in each city would be different from another one. So learning more about the background concept and how we are actually doing this work, let me jump quickly. Because of lack of time, I'm not going to cover the academic concepts that we are actually using to develop the recommendation system. But if you're interested, you can actually refer to some of our publications. The topics that would be of the interest are Tobler's first law of geography, spatial data mining, spatial association rule mining, collocation pattern mining, theory of point process, space partitioning, and recommendation systems. These topics are the ones that we have been dealing with in the past few months. So where we started? We started with the theory, the first theory of geography, which is created by Waldo Tobler. He's known as one of the leaders in development of concepts and theories in the field of geography for past maybe 30, 40 years. And one of his theories that he proposed is known as the first law of geography, which says that everything is related to everything else, but near things are more related than distant things. This is a very big code. And the second law says that the phenomenon external to an area of interest affects what goes on inside. However, I'm not going to use the second law in our work, but I just gave it as a reference if you're interested to follow up the roots. So what we're looking for, let me just dig into the exactly how our system actually works in the backside. Let's take a look on the binary coexistence relationship between two objects. For example, a ferry terminal and the river. The C here represents the confidence of the rule. So, for example, the C here saying that 80%, it means that 80% of the ferry terminals have been close to the river. If we read this rule like that, then it's very easy to read the rest of the rules like as I read now. For example, railway station and the railway route, 99% of them are very close to railway route. Or the ATM machines, 95% of them are located inside the building. But the interesting part is that each city has different rules based on the number of the objects that we find and scan, and also, for example, based on the urban design structures that they have. For example, in Melbourne, where I live, hospitals are usually filling up a very large land area, but there are some cities in the world that the hospitals are actually part of some stories of a very tall building, which could be like a residential building, but some floors are associated to the hospital, which such a thing doesn't exist in Melbourne. Our technique is actually more, it's called as a feature-centric partitioning of space. We use a technique, we use two techniques, like method 1 and 2. Sorry for the mistake that I've made here. Method 1 is the 15 clusters around the center, and method 2 is about 8 clusters around the center. What we do is very simple. We are actually scanning for all, for example, ATMs in Melbourne. This is as an example. Maybe we find 300 ATMs. So we create 8 cluster distances as a circular clusters. We call it do not clusters. And these clusters are actually having the ranges of radius of 50 centimeter, 5 meter, 10 meter, 20 meter, and as you see onward up to 1,000 meter. We don't go beyond 1,000 meter to scan for the objects, but what we do is that we scan all, for example, 200 or 300 ATMs in Melbourne, and we read all the nearby objects in each of these clusters. So we're actually trying to quantize the distance into the clusters. I think if you guess how we are actually doing the distance clustering. We use the different clustering technique as a method 1, but we decided to jump into the different clustering. So we have used those methods to actually scan the objects in each city. This is the some statistics of the cities and point of interest that we have done in our project. We have processed in our project. Paris, Melbourne, London, Amsterdam, Rome, and Jakarta. We tried to select some cities from Europe and also from Australia and also from Asia. Especially Jakarta for us is a new city that we were not actually that much hopeful that we can get lots of information out of it, but actually it was very helpful because the rules we extracted from Jakarta was also very interesting. The sample point of interest that we have, 17 of them, are post boxes, railway platforms, bank, ATM, shopping mall, hospital, and restaurants, but there could be like 1,000 of them. But we only extracted sample list and started to do process. This shows the frequency of the objects that we processed. As you see, the number of the post box and the restaurants or the banks were higher in the number of the existing objects in that total 6 cities. And for example, fire stations or the shopping malls or police stations were lower in the frequency. But still, it doesn't actually matter because we have enough data to do the learning process in our machine learning technique. So let's enough the theory. Let's test it. Let's test the system in real time. I hope that you guys actually can have my screen if I jump back to the system. Because I don't have the feedback, I hope that you have my browser right now. This is the awesome POI analyzer. This is the platform that you can go with the OpenStreetMap.me. When you bring up the platform, we have on the right-hand side 2 methods, as I mentioned earlier, for clustering. So if you choose the method 2, which is the newest method that we are using, and then you can select one of the cities on the right-hand side. For example, I select Melbourne, or maybe I can switch to Paris. And then I can say that, okay, I wanted to register maybe like a playground. And then I can zoom in on the map and say, okay, I'm very interested to maybe register a playground just over here. The system actually gets back to us in just a few seconds, telling us a very quick result. This is embarrassing. It says that it's highly recommended that the position that you click on the map could be used as a playground location. But this probability is based on the technique that we use to calculate. As you see, the normalized score is 73 out of 100, which we actually assume it's a very highly possible position to have a playground. But I'm going deeper into the result when you understand how these scores are calculated. This is a very small primary report that you see in the balloon, but we have a different button here which says generate report. If we click on generate report, it usually takes like a few seconds, but it brings up much more results for you deep into the tables and how the scores are calculated. Might take like a few seconds for the server to process that. Looks like it's coming, yes. As you see here, we have different tables, a bunch of tables that shows you lots of different information. For example, this table shows where I click on the map, this object is actually located inside these type of objects, like it is located in boundary administrator of Paris, and the other thing like the list of objects in radius of 20 meters. But there are other reports like similarity comparison objects that if you're very interested to know how these tables are read, you have to look into our manual in our website, and then how it works. Then you can read and understand what are the vector types and what is the POR and SR, and how we actually calculate the scores on these tables. As an example, we have also developed a technique called the bulk registration that we decided to re-register back all the existing, for example, ATMs in one city. The existing ATM means the ATM that already exists in OSM or database, but we wanted to rank it based on our system and see which ones are outliers. For example, here, what I have done is I have registered some malls, shopping malls in Jakarta. As you see, I have ranked them based on the score, 200 maybe more, if I can dig in that. 300 shopping malls are registered. These 300 are existing at the moment. But the interesting part is that if you zoom in on the map, you see, for example, this one has got the very lowest score based on our system. As you see, the location of the point of interest is outside of the boundary of the building, and it's also in the middle of somewhere very far away from this urban area. So if you look at the scoring, it says that, okay, it gets scored because it's close to the highway primary, it gets some score because it is close to building years and blah, blah. But if we go to the, like other malls that have got the very higher scores, then you see, okay, because it is located in the building years, and also it's also located in the land use commercial, so it gets a lot of score. So this tells us that there is no consistency when the users are adding points of interest to the map, and many of the objects are not properly tagged. That's a very interesting finding over here. But let me jump a bit to another example, like ferry terminals in Amsterdam. We have done the same, and this also shows another example of a ferry terminal that you see over here. It is located over here, and it is there now, but actually it's in the grass area, and it's not a ferry terminal, and it's far away from the body of the water. But it's very interesting, because you can look into these results and even find those bugs in the map that exist. And even this system can help to, in live mode, if we provide the API to the OpenStreetMap, we can actually score any incoming point of interest, and then we recommend them that this location could be accepted or not. We have other different examples over here, but to save the time, I probably have to switch over and go back to the slides. These are some of the results that we have extracted from our system. For example, this is the coexistence ratio between the amenity fuel, which is a gas station, and the highway service. As you see, in all the 6 cities and in all clusters, as you see over here, from 50 centimeters distance to 1,000 meter distance, they're steadily growing up. It means that the coexistence, for example, this one is reading over here as a green for the Melbourne. It says around 30% of the fuel stations are very, very close to the highway service. This is a very interesting rule. But when we go up, and you can see that even within like 500 meters, in most of the cities, almost 50% of the gas stations are close to highway service. Another example is a post box with a post box. It is an interesting example. It shows that if one post box exists, do we have another post box close by? It's like checking the duplicates. But the interesting rule, it shows that even if in all these cities that we have scanned for, in 100-meter distance of one post box, we didn't see any other post box that much. But when it goes further, with 500-meter distance or 1,000-meter distance, yes, there is another post box. For example, 90% is the support rate for this rule in 1,000-meter distance for the cities of Paris and London, as you see on these lines. Another interesting one is a railway platform and railway rail. As you see, all of them actually within 50 centimeters are around zero, but they're all growing up to very large numbers in longer range distances. And the hotel and the building, as you see, all of them are starting with a very high score on the 50 centimeter distance. It means that most of the hotels are registered inside the building, yes. But for example, if we look at the result here in Jakarta, we have 380 hotels in Jakarta. 40% of them are actually inside the building, yes. It means that OpenStreetMap users in Jakarta are not actually tagging the buildings that much. We can actually look into the results in different scope with different lens. This is the coexistence patterns for top 20 popular coexistence objects for the ferry terminal. So as you see on the x-axis, we have listed 20 popular objects, including boundary administrative, a waterway riverbank, and route ferry or man-made pier. So it shows that in all these cities, ferry terminal has a very high coexistence relationship with a riverbank and route ferry and man-made pier. And this is interesting that this rule is actually very similar in most of these 6 cities that we have studied. Another example is the railway platform. Again, you see the railway platform is very correlated with the railway platform, public transportation platform, railway rail, and boundary political. As you see, boundary administrative is always on the first because, of course, most of the points of interest are located inside the boundary administrative. This is another interesting chart. It shows that it shows the reverse side of the work. It says that, okay, what type of object could have a very good relationship with parking in different cities? As you see, shopping malls are having very good relationship with the parking. So if we have a shopping mall, probably, it's a very high probability that we have a parking around. Or we have amenity recycling, or ATM, or hospital. So all of them are saying that, okay, there should be some parking very close nearby. So these charts are actually indicating in a reverse mode. Another example is land use commercial. As you see, like hotels are more or less in most of the cities are located in the land use commercial, shop mall, and then pub and police, which is actually, this one is interesting for us because the police stations are actually located in the land use commercials. This is another interesting one. As you see, for the tag place city, it has been only used in London. So in all the 6 cities that we had, only London, in London they have the tag of the place. But I don't know because I'm not actually very familiar with the history of development of the tags in OpenStreetMap. I've seen lots of presentations and it shows that gradually they have been changed, but people have started to use, for example, boundary administrative instead of using other tags. But it shows that in London still the place.city exists largely there. So our vision for the future of this system, let's say, for example, we have some dreams for the future. We wanted to actually improve what exists at the moment. Our recommendation system should be better and better in scoring. We also want to work on finding random coupled objects to find hidden patterns, because at the moment we're using the feature-centric, which actually we pinpoint each object on the map and when we scan nearby objects. But we wanted to scan randomly and find something out of somewhere, like, we're not sure about the patterns, but something interesting could be there. We're actually also interested in discovering larger co-location association rules instead of only binary rules. At the moment, we're only looking at binary rules, like as you saw here, but maybe there are some other rules like bank, ATM, and hospital. It means that whenever you see the bank, then you see a hospital and also there is an 18 machine inside it. So that's a bigger association rule. And we also want to use deep learning techniques to classify based on clustering attributes. So these are actually some of our targets for the future. Okay, that's time for the party, and thank you for listening. Don't forget to contact us. If you have any comments, more than welcome. Please send me through the email or Skype, and you can also download our presentation or follow me on Twitter. Thank you very much.
Thank you very much for presentation. I'm moderator Hiroshi Mura, and if any questions, please come here and talk here, and then.
I can see, yeah, I can see you.
Hi, thanks a lot for your presentation. My question is, if I want to reuse your software to study my city, for example, the code is available, or there is only the not the source, but I can use it, or I can use it. I want to understand all it is.
You want to use it for what? I didn't get that portion. You want to use it for your own applications?
Yes, I want to know if I want to use your software to study another city, not only.
Oh, yeah, of course.
If the code is available and where, or there is application to download and order.
No. You can contact us. We process it like for each city. Usually it takes 5 or 6 hours processing because millions of transactions should be calculated each time we process each new city. But because of like time constraints, we only process 6 cities in the world. But if you want to have other cities, and having the rules for that, just contact us. We add them all of them to the application, so you can see all the results there.
Okay, thanks.
You're welcome.
Any other questions? Not only for questions and comments or opinions. No? Okay. Give appreciation for the speakers. Thank you very much.
Thank you. Have a nice day. Thank you very much.
Thank you very much.
Thank you very much.
Now, the presentation today is finished. And tomorrow we have the ceremony.